All right. Sorry, I'm going to turn my sound down so that we're not interrupted by notifications that I'm getting on my computer. But anyway, let's look at 1.2. 1.2 is another bunch of definitions like 1.1. Okay, so again, if any of this is old information to you, then just watch the video. Okay, if this is new information, then you might have to pause and write some things down. But definitely, pause the video and write down anything that you haven't ever seen before, right? Anything that you're not familiar with prior to me talking about it now, you should write down. Because on tests and quizzes and stuff, you're not going to have time to rewatch entire videos where we covered material, right? You're going to want to have notes still about things. Not to mention to do homework problems and stuff like that, It's still a good idea to take notes. So definitely write some stuff down if there's anything here that you're not familiar with, that you've never heard of before. Or if you have heard of it before but you're still a little fuzzy on it, like definitely pause the video, take the time to write stuff down. We're going to talk about angle relationships and similar triangles, okay? So first of all, a line that intersects two parallel lines is called a transversal. So what I've drawn here, I've got a couple of lines. They're supposed to be parallel, okay? They're not perfect, but they're close enough, right? So those are parallel lines. And then this is a third line that intersects the two parallel lines, and so that's called a transversal. When you have this transversal situation, you end up with 8 angles that are formed, and they all have special names and properties. So let's talk about each of them. So angles 4 and 5 are called alternate interior angles. Alternate interior. They're interior because they're sort of like on the inside of this thing that is formed by the transversal. So they're interior, and they're alternate because they're on different sides of the transversal, right? So they're alternate interior. 3 and 6 are also alternate interior angles. Okay. Now, alternate interior angles have equal measures. So angle 4 is the same as angle 5. And angle 3 is the same as angle 6. Okay? But obviously, angle 3 and angle 4 are not the same thing. They have a different relationship. Okay? But 4 and 5 are the same. 3 and 6 are the same. So those are alternate interior angles. Angles 1 and 8 are alternate exterior angles, right? Alternate exterior. So they're kind of like on the outside of this box that's formed by the transversal, but they're alternate because, again, they're on opposite sides of the transversal. So 1 and 8 are alternate exterior angles. 7 and 2 are also alternate exterior angles. And just like alternate interior angles, alternate exterior angles have equal measures. So angle 2 is the same as angle 7, and angle 1 is the same as angle 8. Okay. Angles 4 and 6. These are called consecutive interior angles. So interior, again, because they're kind of on the inside of the box. Consecutive, because they're on the same side of the transversal, right? So 3 and 4 are consecutive interior angles. 4 and 6 are consecutive interior angles. 3 and 5 are consecutive interior angles. And consecutive interior angles are supplementary, right? So that, referring back to the previous section, that means that they add up to be 180 degrees. So angle 4 plus angle 6 equals 180 degrees, and angle 3 plus angle 5 equals 180 degrees. One last set of definitions. Angle 2 and angle 6, these are called corresponding angles. Corresponding angles have the same measure, right? So angle 2 is the same as angle 6. 1 and 5 are corresponding angles, so those have the same measure. 4 and 8 are corresponding, so they have the same measure. 3 and 7 are corresponding, so they have the same measure. Okay, So this is the idea behind the transversal and all of these relationships, right? Alternate interior, alternate exterior, and corresponding angles all have equal measures, and then consecutive interior angles are supplementary. In addition, we have the same things as before, like angle 3 and angle 4 would be supplementary angles, right? Because obviously they add up to form a straight line, 180 degrees. Angles 2 and 3 are, we call them opposite angles, and opposite angles have the same measure. So 2 and 3 are the same, 1 and 4 are the same, 7 and 6 are the same, 5 and 8 are the same. Okay. Those don't really have anything to do with the transversal, though. Okay. But they are relationships. They are relationships that should hold. You probably didn't see what I was just pointing to, so let me say it again. 2 and 3 are opposite angles, and they have equal measure. 1 and 4 have equal measure, right? 6 and 7 have equal measure. 5 and 8 have equal measure. So let me walk you through an example. So suppose that L and M are parallel lines. Find A, B, C, and D. So let me draw a picture. So L and M. Okay, so assume that they're parallel. And then let's say that we've got a transversal like that. Let's say that this is angle A. Let's say that this is angle B. And let's say that angle B equals 6x minus 51 degrees. Then let's say that this is angle C, and that this is angle D. And let's say that angle D is 2x plus 61 degrees. Okay? So let's see if we can figure out what angles A, B, C, and D are. Okay. Well, just go ahead and give the video a pause and see if you can work it out on your own. Okay, here's what I'm going to say. So here's my solution. Right off the bat, the information that I have is I have some information about angle B and I have some information about angle D. Moreover, angles B and D are alternate exterior angles, so they have the same measure. So that means that 6x minus 51 has to equal 2x plus 61, right? So I know right off the bat that 6x minus 51 equals 2x plus 61. So I can solve for x. So I can subtract the 2x and then add the 51, 112, and then divide by 4. What do we get? 28, I think. 4 times 8 is 32, 38, 19. Yep. So x is 28. Okay. Now the question is, what are angles A, B, C, and D? Well, x is 28, so that means angle B. That means angle B should be 6 times 28 minus 51. Oh, I'm tired of trying to do stuff in my head. Let me use my calculator. Six times 28 minus 51 is 117 degrees. So angle D should be the same thing. Angle D should also be 117 degrees. Just to check it, though, we could plug in 28 for x there. 2 times 28 plus 61 is 117, right? So B and D are both 117. What should angle A be? So angle A should be, well, it's a supplementary angle with angle B, right? So I'm going to say A is going to be 180 degrees minus angle B, which is 117. And that's 63 degrees. Notice that angle C is also supplementary with angle B. So you could go through the same exercise and say, well, it's 180 minus 117. But you already did that with angle A. Angles A and C are opposite, so they're the same measure, right? So C must also be 63 degrees. So there you go, A, B, C, and D. Not in order, but we got them. Okay, so that's all I'm going to say for about transversals for now, but they'll come up throughout the course. Another important fact is that the sum of the measures of the angles of any triangle is 180 degrees. This is actually true only in Euclidean geometry. There's a whole other kinds of geometries out there, which we're not going to explore in this class. But for Euclidean geometry, yeah, the sum of the measures of the angles of any triangle is 180 degrees. Okay, so if you didn't know that before, it's definitely worth writing down. Let me give you an example of that fact in action. So let's find the missing angle. Okay. I'm being very lax about the terminology. I mean, what I really mean when I say find the missing angle is find the measure of the missing angle, right? But anyway, so let's say that we've got some kind of triangle. It looks something like this. Maybe this is 100 degrees here, 23 degrees here, and maybe this is x, right? So that's the angle whose measure we are trying to find. So we can exploit the fact that the sum of the measures of the angles of a triangle is 180 degrees. So we can say that x plus 100 plus 23 is 180. So obviously, to solve for x, we would just subtract 123. So 180 minus 123 is 57. X is 57 degrees. And that's all there is to it. Okay, here are some more facts about triangles, just some definitions. So first of all, an acute triangle has only acute angles. An obtuse triangle has one obtuse angle, and notice that it can't have more than one obtuse angle, right? Because if so an obtuse angle, remember, means that the angle is between 90 degrees and 180 degrees. If the sum of the angles of a triangle have to add up to be 180 degrees, and you have two angles that are more than 90 degrees, that's not going to work, right? You're going to get more than 180 degrees when you add them up. So an obtuse triangle has one obtuse angle. It can only have one obtuse angle, otherwise it's not a triangle, right? And similarly, a right triangle has one right angle. It can only have one right angle, and the other two angles have to be acute, right? They have to be acute. So in an acute triangle, all of the angles are acute. In an obtuse triangle, one of the angles is obtuse, and in a right triangle, one of the angles is a right angle. And so here's a picture, a kind of a sloppy picture, but anyway, to give you an idea of each of them. So acute, obtuse, and right. Another way to classify triangles is to classify them either as equilateral, isosceles, or scalene. An equilateral triangle has three equal sides, right? So all three of the sides are equal, right? An isosceles triangle has two equal sides. So in this picture, right, these two sides are equal, and this side is it looks a little shorter than the other two, right? So that would be an isosceles triangle. A scalene triangle has no equal sides, right? So in a scalene triangle, none of the sides are the same size. Now, a quick fact about equilateral and isosceles triangles is that if you have equilateral triangles, so if all three of the sides are equal, then it turns out that the angles are also all three the same. With an isosceles triangle, two of the sides are equal, and so the angles made up of the equal sides and the third side are the same. So in other words, those two angles are the same. And then this angle would be different, potentially, right? With a scathing triangle, all three of the angles are going to be different. Okay, so that's that idea. Another thing that we'll need to talk about is triangle congruency, right? So two triangles are congruent if they have the same shape and size. Two triangles are similar if they have the same shape, but not necessarily the same size. So, for example, here would be two congruent triangles. Just pretend that they're exactly the same. I didn't draw them perfectly exactly the same, but if they have the same angles and the same sides, right, same corresponding angles, same corresponding sides, then they are congruent triangles, right? These two triangles, on the other hand, they're similar, right? They have the same shape, that is, they have the same angles, but the sides are obviously different lengths, right? Like this side is much longer than this one. This side is much longer than this one. This side is much shorter than that one, right? But still, because they have the same shape, these are called similar triangles, right? So congruent means they're exactly the same. Similar means same shape but different sizes. Okay. Now, here's a fact about triangle similarity. And I just noticed a mistake, but the following statements are equivalent. Okay? Statement 1, triangle ABC is similar to triangle DEF. That's equivalent to saying statement 2, which is that angle A equals angle D, angle B equals angle E, and angle C equals angle F. Corresponding angles have the same measure. Right? So saying that ABC is similar to DEF is the same thing as saying that the corresponding angles have the same measure. But then the big statement is statement 3, which is it's a very interesting and useful statement, right? So another way to say the same thing as statements 1 and 2 is to say that corresponding sides are proportional. So the ratio of side AB to side DE is the same as the ratio of side BC to side EF, and that's the same thing as the ratio of side AC to side DF. Okay? So maybe a picture's worth 1,000 words, right? So if I've got some triangle, actually I could just use this one, A, B, C, D, E, F. We're saying that if I compare this side, if I divide this length by this length, I'm going to get the same ratio as I would get if I divided this length by this length. And that's going to be the same ratio as if I divide this length by this length. What you can't do is say that this over that equals this over that, right? You've got to go the same direction. You would say this over that equals this over that. Another thing you could do actually is you could say this over this equals that over that. That would also be a valid thing to say. Okay, so the ratios of corresponding sides are the same, or in other words, corresponding sides are proportional to each other. Let me give you an example of this fact in action. So let's suppose that triangle ABC and triangle DEF are similar. And let's find the missing side lengths. Okay, so let me draw a picture. All my triangles end up looking the same. A, B, C. And let's say that that side is 6, this side is 9. I don't care what, 6 centimeters, 6 inches, 6 yards, whatever you want them to be. And then D, E, F is going to be similar. And we know that this length is 3. So now, find the missing sides. So we want to find this side. We also want to find these two sides, right? So how are we going to do that? Well, we know that ABC is equal to, or is similar to DEF. That means that the ratio of this side, the ratio of this side to this side is the same thing as the ratio of this side to this side. So that gives me a way to find out what the length of DE is. Right? So we can say, you know, AC over DF should equal AB over DE. Well, AC is 9, DF is 3, AB is 6, and DE we don't know. We'll just leave it DE. 9 divided by 3 is 3. I can multiply both sides by DE and then divide by 3. So I'm going to say 3DE equals 6. So DE equals 6 divided by 3, which is 2. So DE is 2. So we've got that one now. So now we need to find this third side. Well, can we do that? I think we need to know at least one of them. I think we need to know one of these lengths so that we can find the other one, right? Let me think about it. Yeah, I think that's all we can figure out on this one without knowing the length of one of the other sides. I don't think we can find the length of the third one. Yeah, there's no way we can find the length of the third one. So I have just given us a bad problem, I guess. Maybe, so let me fill in, let me say that this one was, what do we want to make it? Maybe 2.5. Then we can figure out what BC is. We could say, same thing, right? We could say 9 over 3 equals BC over 2.5. 9 divided by 3 is 3. 3 times 2.5 is like 8.5, I think. Is that right? 3 times 2.5, 7.5. I overshot a little. Anyway, so BC would be 7.5. Okay, anyway, that's the idea there. So, one more problem. And it's a word problem, so once again, I'm not going to like write it out. But I'll work it out here. So it says, a forest fire lookout tower casts a shadow 180 feet long. Oh, I need to fix this too. I put 2.5 here. So next time I do this lecture, I don't make that mistake again. Anyway, a forest fire lookout tower casts a shadow 180 feet long at the same time that the shadow of a 9-foot truck is 15 feet long. How tall is the tower? So I think what we have here are similar triangles, right? So a forest fire lookout tower. So I'm going to say that this thing is the tower. And it casts a shadow that's 180 feet long. So this is the shadow of the tower, right? And, you know, it didn't say anything about this third side, but you can see that it's a triangle. In fact, it's a right triangle. Okay, so that's the tower. Now this happens at the same time that a 9-foot truck casts a shadow that's 15 feet long. So it's a 9-foot truck, and the shadow is 15 feet. Okay? And the question is, how tall is the tower? So what's this length here? And clearly, these angles are going to be the same, right? So this angle and this angle is going to be the same because the sun, right, is in the same location. It's the same time of day. So maybe the sun is out here somewhere, right? So it's the same time of day, which means that the sun rays are coming down at the same angle on both of these things. So if these are both 90-degree angles and these angles are the same, then that means these angles must also be the same, right? So these angles must also be the same. If that's the case, then we've got two similar triangles, right? These are similar triangles. All three of the angles match, right? All three of the angles match. That's the same thing as saying that the two triangles are similar. Well, if the two triangles are similar, then corresponding sides are proportional. So we can say something like 180 over 15 equals x over 9, right? Oh, well, whatever. 180 over 15 equals x over 9. Does 15 go into 180? Oh, I think it does, actually. Yeah, 12 times. So 12 equals x over 9. Now I just need to divide or multiply by 9. 12 times 9. X is 108 feet, right? So the tower is 108 feet tall. Okay, and that's how that one works, right? So that'll do it for this section. We'll see you in the next one.